Hey guys, how's it going? Let's go over problem set 3.2 here with a video key. Okay, I've already filled out some of this stuff here. So it's parallel postulates and theorems. So the big thing here is if two parallel lines are cut by a transversal. So they have to be parallel. Okay, that's kind of the key here. So if two parallel lines are cut by a transversal, then the following things are true. Corresponding angles are congruent. Alternate interior angles are congruent, and you can just call that AIA for short, as we get into proofs later. Consecutive interior angles are supplementary, okay? So that means they add to 180 degrees. And alternate exterior angles are congruent. So consecutive interior angles you can call CIA, and then AEA for alternate exterior angles theorem. Okay, so let's look at the figure here. And it says are angles 2 and 6 corresponding angles. So remember, corresponding angles are on the same side of the transversal, kind of like in the same location. So yes, they are corresponding. And it says, well, explain why they are clearly not congruent despite the corresponding angles postulate. So remember up here, the corresponding angles postulate right here tells us that corresponding angles are congruent. But remember, these things up here are only true if the two lines are parallel. So if we come back down here, these two lines that are cut by the transversal are clearly not parallel. And therefore, the corresponding angles postulate is not true. So since these lines are not parallel, the corresponding angles postulate doesn't apply. Does not apply. And it's exciting, so put an exclamation mark at the end. All right, so here's an old school problem. This was actually on, like, you guys don't take the OGT, but this was on a standardized test from a long time ago. It says, so we have a worker painted stripes for spaces in a parking lot. The worker first painted a center stripe that marked the front of the parking spaces. So that's talking about this one. Here's your center stripe. Then he painted parallel stripes marking the sides. So these are all parallel, all these going this way. Which angles will be congruent to angle 1 if all the side strips are parallel? So what we have then is corresponding angles right here and right here. So angle 3, but then 3 and 4 are vertical angles. So angle 3 and angle 4 are congruent to angle 1. Okay. All right, so let's use this picture for numbers 3 through 6, and we'll state the theorems or postulates that we use in each problem. So kind of a little mini proof here, really. So we have the measure of angle 1 right here, and the measure of angle 4. Okay, those are alternate exterior angles. And if you come back up here, we know that alternate exterior angles are congruent. Okay, and these little marks right here, this one and this one, are indicating that those lines are parallel. Okay, that's what that shows us. So we know the lines are parallel, and therefore alternate exterior angles are congruent applies. So alternate exterior angles are congruent. Remember our symbol for congruent there. And so we can set angle 1, which is 2x minus 8, equal to angle 4, which is 72, and solve, and you get 2x equals 80, so x equals 40. Okay. Number 4 says that the ratio of measure of angle 6 to angle 8 is 4 to 5. Find the measures of angles 6 and 8. So these are consecutive interior angles, okay, and they are supplementary. Remember, consecutive interior, same side of the transversal. So here's our transversal right here. They're on the same side, and they're both inside. So consecutive interior angles are supplementary. Okay, it's going to be hard to remember all these different things, like the wording, so just have it ready and keep looking back and forth. So we know that these are supplementary, and if the ratio is 4 to 5, that means 4x plus 5x will equal 180. That gives us 9x equals 180, which means x equals 20. And now we can plug our x into 5x and 4x to get our two different angles. Angle 6 is smaller because it's 4 to 5 compared to angle 8. And so angle 6 is equal to, the measure of angle 6 is equal to 4 times 20, which is 80 degrees. And the measure of angle 8 is equal to 5 times 20 using this, which is 100 degrees. And that makes sense because they add up to 180, which we knew they had to because they're supplementary. Okay. And then number 5, we have angles 5 and 7. We have to find the measure of angle 8. So what do we know about 5 and 7? We know the same thing from above. Consecutive interior angles are supplementary. Okay, so we can use this again. Copy and paste. And so we know that those two are going to be equal, or sorry, add to 180. 2x plus 36 plus 4x plus 24 equals 180. Combine some like terms here and get 6x plus 60 equals 180. That gives us 6x equals 120, and therefore x equals 20. Okay, now we're comparing angles 5 and 8. Now 5 and 8 are alternate interior angles, and those are congruent. So I'm going to do this in a different color. So now we're going to use alternate interior angles are congruent. Okay, so we know angle 5. So I'm going to use angle 5 right here, knowing that x is 20. And so the measure of angle 5 is equal to 2 times 20 plus 36, which is 76 degrees. And therefore, the measure of angle 8 is also equal to 76 degrees because alternate interior angles are congruent. Remember, alternate interior. Alternate means on the other side, opposite sides of the transversal, and interior means between these two lines. Okay? And now number 6. So we have angles 3 and 7, which are right here. And those are corresponding angles. See how they're like both in the upper left corner there on the same side of the transversal. So now we have that corresponding angles are congruent. So corresponding angles are congruent. That's what we're using here. So we know that x squared minus 3x plus 12 is equal to 8x plus 24. That'll give us x squared, so subtract 8x, and you get minus 11x, and subtract 24, and you get minus 12 equals 0. So we get x minus 12 times x plus 1 equals 0. So we get x equals 12 or x equals negative 1. And then, so it says find all possible values of x. Sorry, I didn't read the question to you. Find all possible values of x and the possible measures of angle 3. So the measure of angle 3 we know is given by this. Okay, so we're just going to plug in our x value for that. So the measure of angle 3 is equal to 12 squared minus 3 times 12 plus 12, which is equal to 120 degrees if you calculate that. Okay, or we have the measure of angle 3 is equal to negative 1 squared minus 3 times negative 1 plus 12. And that's going to get us 16 degrees when you simplify that. Okay, and then the last problem here, a little challenge problem. Find the values of x and y. So first what we know is that these our corresponding angles, which we know are congruent. So we can say 13y is equal to 20x plus 3y. Okay. Now we have two variables here, so this is a little weird. I don't know if you guys remember systems of equations. So you get 10y equals 20x, divide by 10, you get y equals 2x. So now we know y equals 2x, and what we also know is that these two angles are a linear pair, and so they add up to 180 degrees. So let me shrink this down a little bit here, get it out of the way. So what we can do now is say that 13y is equal to, 13y plus 8x plus y. So adding these together, we know it's going to be 180 degrees. And then we know that y equals 2x. So first we can combine our y's right here. Combine these like terms. Get 14y plus 8x equals 180. And then since we know y equals 2x right here, we can substitute for that and get 28x plus 8x equals 180. Combine like terms to get us 36x equals 180. Divide by 36 and you get x equals 5. And then our job was to find the values of x and y. But right here, we know that y is 2 times x. So if x is 5, then y equals 10. And there you have it.